Namaste. This is JV and Dr. Vishal Saxena, Professor in Mathematics in Faculty of Education and Methodology, Jaipur VIDYAPEETH Women's University, Jaipur. So today I'm going to take a lecture on the module addition rule, and that is also known as addition theorem in probability. This module belongs to the course Research Methodology and Biostatistics in under the program of B Pharma 8th semester and BPT 6th semester of the university. So today we are discussing on the topic on addition rule. So this just describes the theorem, and that will just give you the probability for the two or more events in the combined day. So just when the two events or more events just combine to each other, then we can able to find the probability for the such two events by this rule. And beside this, I am going to discuss also on the multiplication property in the probability today. So for this, I am going to share some slides to explain these topics more. We can see on screen our addition rule, and the addition probability theorem is given that. So this theorem is just describing here for the two events A and B. So first we have to understand for the two events A and B, there are two possibilities for the two events. One is that the two events A and B may be mutually exclusive events. And second case may be possible that the two events A and B may not be, may be non-mutually exclusive events. So in the last lecture, we have discussed about the mutually exclusive events. Again, I'm telling you this one. The two events are called mutually exclusive when the occurrence of two events cannot possible simultaneously. It means the two events cannot exist simultaneously. For example, when we roll a coin, when we throw a coin, then there are two possibilities of coming. One is head and second is tail. But these two events means coming of head and tail are not possible at the same time. So such events are called the mutually exclusive events. And those events which are not mutually exclusive events are just called non-mutually exclusive events. In the addition rule, we have to describe the two possibilities for the two such events. So in the first case, in the case one, we are going to take the two mutually exclusive events. Suppose the events are A and B. If events are A and B, then their union probability means P A union B is showing that the probability of event A or the event B or the probability of event A and B both. So it means the probability A union B is the probability of event A or B or both events. Just it is also written by PA or B, and that is equal to PA plus PB. PA plus PB means the simple sum of algebraic sum of the two probabilities of event A and B separately, and that is called the addition rule or the addition property in the probability. Here one point that is to be noted is that the probability of A intersection B event is not coming there, because the two events are mutually exclusive. Therefore, the common event A intersection B does not occur here, and therefore its probability will be 0. And that's why just probability of event A union B is given by PA plus PB. Next, in the same way, we can extend this theorem for the two or more events, like for 3 events, for the 4 events, and so on. So if there are 3 events, then we will say PA union B union C equal to PA plus PB plus PC. Now, next we discuss on the second kind of events. That means when the events are non-mutually exclusive. Non-mutually exclusive events, and in that case means there is some possibility for the 2 events that is common event. Uh, Now in this case, what happens? The probability of A union B is given by probability of event A plus probability of event B and minus probability of event A intersection B. Probability of event A intersection B is also written as a PAB. So finally, this PA union B means what is PA union B showing here? PA union B shows that the probability of event A or the event B or the 2 events A and B, and that is given by PA plus PB minus PA intersection B. Now we are coming on its a proof, because in mathematics that is very important, just how to prove a theorem. So let us see how can we prove this theorem. Suppose that the 2 events A and B be any 2 non-mutually exclusive events. So it means we are taking this case, case number 2, in which the 2 events A and B are 2 non-mutually exclusive events. Okay. So in this case, there is a possibility events of a random experiment with sample space S. So finally, just we can say that if a Venn diagram is made there, then we can see there A, comma A intersection B and only B are the mutually exclusive events, and their union is A union B. It means in a Venn diagram, we can observe that the events A and A intersection B and only the event B, that is a separate part, just will give us the the union of the union of 2 events A and B. And it means we can write in this way: probability of A union B is equal to probability for the event A, only event A. Here just we are taking only event A, union probability of A intersection B and union of only event B. So what is coming there? Only A and union with A intersection B and union with only event B. But as already we can we have explained that in a Venn diagram, such events are the independent events. Independent events means those events which does not affect each other. So in the present case, the only event A and the event A intersection B and the event only B just are independent. And by the law of the independent events, their probabilities in the case of union just will be the simple addition of their individual probabilities. So that means probability for the only event A plus only event A intersection B and probability for only event B. And now we just take this part as PA minus PA intersection B. PA minus PA intersection B plus PA intersection B plus PB minus PA intersection B. Just this equation is written in a different way to obtain the desired result. So just we have taken in this way and we have put the value of P for the only event A and P for only event B. So finally, on solving this equation, just by cancellation, some terms, look at this one, just we will get the desired result. Probability for A union B is equal to PA plus PB minus PA intersection B. And this is the theorem. This theorem is known as the addition theorem for the probability. Now we take an example to explain this more. Suppose in this example, a shooter is known to hit a target 3 out of 7 shots. Again, see the question. A shooter is known to hit a target 3 out of 7 shots means ultimately we can find the probability of hitting the target by that shooter. Second, while another shooter is known to hit the target 2 out of 5 shots. So this will give us the probability for hitting the target by the second shooter. Find the probability of the target being hit at all when both of them try. So when both of them will try, so we have to find the probability of hitting the target by anyone. So how can we solve this question? So look at this one here. First, we have to see this one. Probability for the first shooter hitting the target is 3 by 7. Just it is given that. So the probability for hitting the target by the shooter A is given by 3 by 7. Then the probability for the second shooter who hits the target is given by PB equal to 2 by 5. Now, the two events A and B are not mutually exclusive. As both the shooters may hit the target, that's why means both the shooters can hit the target simultaneously. So the two events are not mutually exclusive, and therefore the addition theorem for the probability will give us PA union B is equal to PA plus PB minus PA intersection B. That means this equal to 3 by 7 plus 2 by 5 and minus PA intersection B. PA intersection B can be written as 3 by 7 into 2 by 5 because ultimately the two events are independent to each other. Therefore, PA intersection B is given by 3 by 7 and 2 by 5. And therefore, the probability of A union B is given by 23 by 35. So in this way, the addition rule can be applied for solving such type of problems for finding the probabilities for only the case of event A or the event B, or sometimes both the events A and B. So that is the method. Now we take next. Now this is the Venn diagram. Just Venn diagram is showing that the probabilities of two events A and B. This part, the common part for the two events is given by A intersection B. The left hand side part which is enclosed in the circle A, that is called only A, and in the second circle only B part is given, and in this way the addition theorem can be understood. Next we are going to take one more question to explain this addition theorem more. What is the probability of drawing either a king or a queen in a single draw from a well-shuffled pack of 52 cards? So in this question, we are having a pack of 52 cards and the question is to find the probability of drawing either a king card or a queen card in a single draw. So it means just how can we solve this question? Total number of cards, as already we know that the total number of cards are 52. Next, the number of king cards, is 4. probability for the drawing a king card is 4/52. That is important. Means the probability for drawing a king card is given by 4/52. 4/52 means the number of favorable cases to the event divided by the total possible outcomes. So 52 possibilities are there and 4 king cards are there. So ultimately the probability for drawing a king card is 4/52. And in a similar way, the probability for drawing a queen card from this well shuffled pack of cards is given by 4/52. Now, what is the question? Question is that just what is the probability of drawing either a king or a queen? So it means we have to find the probability of A union B, event A union B. Then it means P A union B is equal to PA plus PB. And just why we have taken this one, PA plus PB. Why the term of PA intersection B is not coming there? Because the two events means drawing a king card and drawing a queen card simultaneously means in a single draw just shows the two mutually exclusive events. And that's why in the case of mutually exclusive events, PA union B is given by PA plus PB. And therefore, the probability of drawing either a king card or a queen card is given by 4/52 plus 4/52. That means it is given by 8/52 and which is equal to 2/13. So this is the addition theorem or the addition rule for the probability. And this is one of the important part of probability concepts. In the later topics, we will discuss the probability distributions. So where just we will find the probability for the such two different possible distributions, discrete probability distribution and continuous probability distribution. Now, one more thing. That is called the multiplication property in the probability theory. What it is here? Actually, it is obtained by the concept of the conditional probability. Conditional probability PA by B is equal to PA intersection B upon PB. So PA by B, that means it is the conditional probability of event A when the event B has already occurred, and this is equal to PA intersection B by PB. When we cross multiply these two terms, then we will get probability of A intersection B is equal to PB into PA by B, and this can also be written as PA intersection B is equal to PA into PB by A. So means that two different statements can be given for the multiplication property for the event for the probability of event A intersection B. And in this property, we can find the probability for the common part for the just occurrence of both events A and B by this formula. And again, this is an important part of the probability theory and which would be much helpful for solving the questions of probability and probability distributions. So now I'm concluding my today's lecture. Thank you.